Welcome everyone. In this video we will derive the formula for finding the derivative of the product of two functions. So our goal is to find dx of the product of two functions, which I will call the first function g of x and the second function h of x. So this is the derivative that we want to evaluate, and we will actually find a formula for it that we can use in a bunch of questions in a bunch of places. So how can we do this? And before finding the correct formula, I want to show what can't be the correct formula. So it might be tempting when you look at this derivative, you might be saying, why can't we just say that this is equal to the derivative of the first function times the derivative of the second function, right? I mean, can't we just distribute the derivative here? Well, the answer is no. You cannot do that. This is not equal to this. So the derivative of a product is not equal to the product of the derivatives. But why is that not the case? Well, you can think of this. You can think of this by considering the units of both sides of the equation. So let's say that, let's make this a physical example instead of just mathematical. Let's say that we have position x and we are taking its derivative with respect to time. This would give us velocity. Now, and I'm not using vector notation to not make things confusing. If we have this, we know that x is represented in meters and time is in seconds. So the velocity is, of course, in meters per second. Well, if we apply this to the formula that we have, you are saying that if we apply it to to our case, maybe you have a position. G of x maybe represents the position. So you have something in meters times. Maybe h of x represents position as well. So you have another meters. And now, instead of taking the derivative with respect to x, let's take with respect to t. So you are taking the derivative of meters times meters squared. Meters times meters, so meters squared. You are taking this derivative with respect to time, so you have second as the left side, as this part. Well, what do you have on the right side, on this side, I mean? Well, you have the derivative of g of x. It was position in our case, so you take its derivative with respect to time. You have velocity, which is meters per second, times you have another velocity, meters per second. And obviously these are not equal. Even the units don't match. So it is obvious when we think like this that it is not correct to say the derivative of a product is equal to the product of the derivatives. You cannot distribute the derivative like this. You can't do that. So let's do the right way. Let's find the right formula that we can use. And maybe at the end we can even do a unit check, or you can do a unit check yourself. So the way I want to approach this problem is, I want to first write the definition of a derivative. The definition of a derivative is as follows. If you want to find f prime of x, which means the derivative of f with respect to x, this is simply equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x, all of which is divided by delta x. Now, this is the general formula for the derivative. This is the definition, one of the definitions of derivative. Now, let's apply this to our case. In our case, and I'm going to write this in red because it is important. In our case, f of x is equal to g of x times h of x. So the product that we are trying to take the derivative of is our function f in this case. So we are actually interested in finding what happens when we plug in g of x times h of x in this formula for f of x. And if we analyze if we analyze this part here, this is simply meaning the value of the function f evaluated at x plus delta x. So this is the same thing as maybe you had an f plus you added an delta f to it. You were at point x and then you moved some distance delta x, so now you have your old value of f plus the distance that plus the change in f that corresponds to the distance that you traveled. So we can think of it like this. Sorry. We can think of it like this. Then for our case, f plus delta f will be, if you look at this, if you look at that, this will be g plus delta g times h plus delta h. Now, we got that out of the way, and what is this part? What is f of x? Well, it is simply the initial value of your function f evaluated at x. You didn't move delta x in any direction right now. You are just at the point that you are, and you are evaluating your function there. So we simply have f. We don't put a plus delta f because, as I said, we didn't move in any direction. There is no change in our f. This is f, and, well, if we look at the definition that we made here, this is simply equal to g times h. And notice that I am not putting x's here, not f of x, not g of x, not h of x. You could do that, but I am not writing that. I am not doing that to keep it shorter, actually. Yeah, I don't want to take a lot of space. So imagine wherever we have f, I am talking about f of x. Whenever we have g or h, I am talking about the functions. Right? These aren't just variables. These are functions. So we got that, and now we are ready to take the derivative then. Instead of, let's do this as well. Instead of f prime of delta x, we will have what we are interested in. And maybe I should write g of x and h of x here. So this is equal to the thing that we are actually trying to evaluate, the derivative of the product. So let's get started. And I want to do it on a new page. As I said, on the left we have the derivative of the product, what we are trying to find. So I wrote it here. This is equal to the limit. It is equal to the limit as delta x approaches 0. And that's not a nice looking delta there. So let's make it better. Oops, sorry about that. Delta x. Okay. And now let's write what we have for the numerator and the denominator. So we have this first term, which we set that equal to this product. So I am writing it, and let me go back. Yep. So I am writing that g plus delta g. I hope my g's don't look like nines there, but you have the context, so you should be able to understand, I hope. Anyways, we wrote the first term. It was this product here. Then we have the second term, which is minus f of x, which I said is g times h, of course with the minus sign. Minus gh divided by delta x. Well, we will still have our limit as delta x approaches 0. For the numerator part now, I want to expand the first term. So if we expand it, I'm just going to multiply these two, g times h, then g times delta h times g, then delta h times delta g, like that. You probably know what I'm talking about. We multiply the two factors that we have in the first term, delta gh plus delta g delta h minus gh divided by delta x. Now we see a great thing. We see that this and this cancel. And if we take the limit now, if we use this limit notation here, we can simplify things even further. Because if we apply the limit to this part, delta h the delta h divided by delta x as delta x approaches 0? Well, this will simply give us the derivative of h. This is by the definition of derivatives, right? So the first term gave us g times the derivative of h prime. All right, and now actually I will write the x's inside the parentheses as well. Okay, this is what we got from the first term, so this one is checked. Now for the second term, for this one, we have at times h of x, times delta g over delta x as delta x approaches 0. Well, this is the definition of the derivative of g of x with respect to x. So we simply get g prime of x. As a result, this part is checked as well. Now for the third term, this term, we have delta g times delta h divided by delta x. Maybe you want to evaluate it like this. You have limit delta x approaches 0. Maybe you evaluate delta g over delta x, which gives you g prime of x. Right, it gives you g prime of x. And then you still have delta h. The key here to understand is if you have delta x approaching 0, you also have delta g approaching 0 and delta h approaching 0. So this delta h term here, this factor, it goes to 0, which means the whole third term goes to 0, which leaves us with the equation that we were seeking, we were hoping to prove, which is g of x times h prime of x plus h of x times g prime of x. This is the formula for finding the derivative of a product. What you do is you take the first function, multiply it with the derivative of the second, then you add it with the second function times the derivative of the first function. Right? This is the derivative of the product is equal to the formula that we just derived. I hope that this video was helpful. If you have any comments, please write them in the comment section. In a future video, I hope to prove the formula for finding the derivative of a division. So stay tuned for that and hope to see you in another video. Until then, take care.